Short question. Okay, so
I had a question. This is very loud, sorry. Whether there was a problem associated with the difference between the clear sky normalization and the actual condition with respect to season. Because in my mind, at least, it seems like we have more sunny days in certain seasons, and then other seasons are more subject to variability. Is that something that just looks like a stochastic, or?
Well, we have to consider that clear sky condition is a sort of ideal condition. So, clear sky condition, we can compute them analytically because you assume that because you know you can compute the solar irradiance under clear sky condition, and this solar irradiance varies from day to day. So you have a different clear sky generation for each day of the year, and this quantity can be computed, let me say, analytically. Okay, so I don't know if I.
Yeah, I think what I was saying was, if you're doing a comparison between the two of them, and one season adheres much more closely to the clear sky normalization, whereas another season may deviate from it a lot more.
Now, that actually is not a problem, because what you do, you consider normalized power. So you take your data set of generated power and just divide the actual generated power by the clear sky power that you would have generated in that day. So basically, the difference between the actual generated power and the clear sky one is captured by this ratio, in some sense.
Thank you.
okay, thank you. And I have to move on. Yeah. And the first speaker is Professor Anthony Deese from College of New Jersey.
Okay, great. Good afternoon or good morning, everyone. I'm Dr. Anthony Deese from the College of New Jersey. My co-authors are shown. One of them is my former doctoral advisor, Dr. Chikanwanga from Drexel University. I think I was the one who referred to a lot of slides initially. I do have a lot. I'm going to go very quickly through some of them and more slowly through some others. So this work is an expansion upon some of our previous research, as well as research of other colleagues from other institutions on the subject of analog emulation of power system dynamics. So here we have, well actually up here, we have some pictures of our previous prototypes. We developed three. Moving from left to right, we have the oldest to the most recent. The left-hand side prototype used traditional analog components, amplifiers, chips, and such, whereas the second and third use field programmable analog array or FPAA technology. Unfortunately, in this presentation, we're not going to have the opportunity to discuss these too much. We're going to discuss some corollary topics. So, just to do a little bit of a recap, we will discuss exactly what analog emulation is. I'm sure many of you are familiar with the whole concept of analog computation, although it's not really used that much anymore. Essentially, right, you build an analog circuit that emulates the dynamics or the behavior of your system. You initialize the circuit, allow it to settle, and then you observe the result. Obviously, today, analog computation emulation is not really a very popular technology for analysis of nonlinear systems and different types of complex systems. Digital simulation is much more prevalent for a number of reasons. It's more flexible, easier to configure, more precise, smaller, cheaper, less power hungry. All in all, the prevalence of the digital or the PC today makes simulation a much more attractive option. Now, given that, why would we even care about discussing analog emulation at all? One reason is improvement in analog technologies. The field programmable analog array, FPAA, although it's still sort of a niche market, it has brought a lot more capability to the analog designer. But I think the main advantage is speed. This is what we focus on in a lot of our previous works. So with analog computation, we're able to perform faster than real-time power system analysis or load flow analysis. The emulation doesn't use iterative numerical techniques like the number absent, and as such, computation time is independent of the power system size and complexity. So with regard to motivation for this work, the main motivator was the lack of